Hey, what's going on, everybody? Mr. Cornell here, going to be going over some trig identities with you. Hope you're all quarantining well, staying safe, trying to kill as much of the boredom as you can. It's been a long haul, I know, for everybody, but we do what we can. So let's go over lesson 11-6, simplifying some trig expressions and proving some trig identities. So some of it is a little bit new. A lot of it kind of piggybacks on some old things that you should I kind of remember from what we've been working on, and it's just going to take old stuff and new stuff and make this stuff here. All right, so let's start with Pythagorean identities. So the Pythagorean theorem, a squared plus b squared equals c squared. Now we're moving into trig stuff here, so it's actually now going to be sine squared theta plus cosine squared theta is equal to 1. Now, from here, I can do anything I want to this. So for example, if I wanted to know what is cosine squared theta by itself, you would move this sine squared theta to the other side by doing minus sine squared theta. So you could rewrite this as cosine squared theta equals 1 minus sine squared theta, just from taking this guy and moving the sign over. And then the same thing with the cosine. So if I wanted to get the sine by itself, you can move the cosine to the other side, and you would have 1 minus. So sine squared theta, that's 1 minus cosine squared theta. So these are all the same, but they're all coming from this guy here. So if you kind of have this guy memorized and understand like where he's coming from, then you can create those other two equations there. Reciprocal identities, we've done those before, and that would be that sine, that you have sine theta, and then his inverse function is cosecant, and that's the same as having 1 over sine theta. Then you have the secant. The secant is the inverse of, and that's having 1 over cosine theta. And then you have the cotangent, and then the cotangent is coming from 1 over tangent theta. And we looked at those at an earlier lesson. And then you have quotient identities, and that's kind of building off of tangent theta. So now you have tangent theta, which is the sine of theta over the cosine of theta. Then you'll have the cotangent of theta. So think about it. All of these here, it's like reciprocals. So you take the reciprocal of tangent, which we're now calling sine over cosine. So you just flip that, so that becomes cosine over sine. So that's all you need to know for today's lesson, because everything else that we're going to do, you've done before, just in different forms. So if you take a second and just really kind of take a look at this, I don't want to say memorize, but really kind of become familiar with what we're looking at here, then you'll find the rest of this lesson to be probably pretty easy. So let's take a look at this. So baby proofs. So using these identities, write an equivalent trig function for each of the following expressions. So it's basically saying, okay, change it around so that they're equal to each other. So if you look at this one, it's saying 1 minus sine squared theta is equal to cosine squared theta. So in the end, I could change this. Now if you look, we were talking about that up here. Cosine squared theta is the same as 1 minus sine squared theta. So you could just rewrite that like that instead, and now the two are equal. Or you could play the game vice versa. You can change cosine squared theta into 1 minus sine squared theta. Okay, it's the same thing. So there's one of your baby things there. This will make more sense to you. Cosine theta times secant theta equals 1. So basically, can we turn this into a 1? Whenever you're doing these kind of questions, you try to see if you can get into that sine or cosine function. So we would turn the secant from our trig identities up here, or reciprocal identities. Secant is the same as having 1 over cosine theta. So then you leave the cosine theta. Now you're basically multiplying, and these guys cancel, and you're left with 1. So 1 is equal to 1. That's what you're looking at there. Let's try this one. Secant theta, again, is the same as 1 over cosine theta. And then we'll leave the other one of sine theta. And that's equal to tangent theta. Now, if I go ahead and multiply these, sine theta times 1 is sine theta. And 1 times cosine theta is cosine theta. And if you looked at what we wrote up here, tangent is equal to sine theta over cosine theta. So you can turn this into that, and then the two are equal. All right. Maybe give it a pause, try D, E, and F. Maybe you won't get it, but maybe you'll see something that you're supposed to change. To see if you can kind of start identifying who you should change into what to try to make these equations equivalent. All right, so here I notice right away I have cotangent theta. Now, cotangent theta, there are two cotangent thetas, right? One of them was this one, 1 over tangent theta, and one of them was this one. They're both the same. It's just one might help you in one situation where another might help you in another situation. It doesn't matter which one you use because in the end you're going to get back to the same thing. So let's do both of them and see. So if you tried this on your own, then cool. Then just see what you got. Maybe you did 1 over tangent theta, and then you got cosine theta, and then maybe you got stuck here. Tangent theta, right, is the same as sine theta over cosine theta. Okay, now this is kind of a good one to pay attention to, and you'll see how what I mean when I say that it doesn't matter which one you use, you're going to get back to the same thing in the end. Remember when you have a fraction divided by a fraction, like something like 3 divided by 2 into 5, right? This is all the same as having, say, 3 times 5 over 2, right? You're taking this bottom fraction and you're taking its reciprocal. So 1 divided by sine divided by cosine is the same as having cosine divided by sine. Now, these guys would cancel, because one's the numerator, one's the denominator, and you're left with cosine theta equals cosine theta. We'll get to that again. Or you did this. And that's why I say certain ones in certain situations might help or work better. Cotangent, maybe you didn't use this one. Maybe you just use this one right away. Is the same as having cosine theta over sine theta. So then, bam, those guys cancel, and you're left with cosine theta equals cosine theta. And you're done. All right? And you're like, well, why didn't you show me that from the first place? Well, I don't know. Because it's math. I have to make it confusing and hard for a little bit. All right, let's try this one. 1 minus cosine squared theta. Where did we see that before? Well, we saw that up here with our triples, right? Our Pythagorean identity. Cosine squared, 1 minus sine, 1 minus cosine. So this is the same as just having this. Now this is squared, which means there are 2 of them. So you can really cancel one of them, and you'd be left with sine theta equals sine theta. Again, just to clear up confusion, sine squared theta is like having sine theta times sine theta. And that's why these guys cancel, and that's why you're ending up with this. All right? Now, this whole mumble jumble we did before, now you'll see why. Tangent, again, use the one that's going to make the most sense in the problem. This one has a sine in it, so I'm not going to use tangent, and I'm going to use it sine over cosine, right? So you'll have sine theta theta over cosine theta. This came from changing this, right? Now, what do you do when you have a fraction over a fraction? Flip this fraction. So I have sine theta. Now, instead of having division, I'm going to have multiplication. And I flipped it. Okay, equals cosine theta. Cancels, cancels. Cosine theta equals cosine theta. And my face might be blocking this, but I don't know. I wrote it. I said it. You can listen. All right. There we go. So let's keep it going. Here are some good tips that you should take note of. Try to read. Make sure that you're kind of familiar with these tips. Writing, again, trying to get sines and cosines. Remember that sine squared theta plus cosine squared theta equals 1 can be converted into here. Sometimes you might have to do GCF, like if you had, say, sine squared theta plus sine theta times cosine theta, right? This technically can get factored out, right? Because they both have a sign there. If you have numbers, you can always kind of divide don't forget rules with numbers, dividing fractions, doing the flip, double distributing, conjugate is the same as doing sine theta here. So yeah, those are some good tips, and now we're just going to keep practicing. So if you want to hit pause, practice, see how good you are, check your answers, might go a little bit quicker for you. All right, so here we go. Simplest form. Cosecant theta times tangent theta times cosine theta. So cosecant is the same as 1 over sine. Tangent, we said, was sine over cosine, right? And cosine, I don't really have to do anything with. So that changed him, left him the same. Cancel you, cancel you, cancel you, cancel you, left with 1. There you go. Here we go. Let's write it like this over here. Cotangent x cosecant x. So cotangent was the same as cosine over sine. Cosecant is the same as 1 over sine. Okay, so here you have your fraction divided by a fraction. So we'll cancel it. We'll flip this, right? So you're going to have cosine x sine x, and then that's sine x over 1. Cancels, cancels. This is what you're left with. So it's kind of taking your time. It's learning all the rules and all the things that you can do with those rules. All right, so here's kind of a crazy one here. You could decide to distribute and then start plugging in, or you can plug in and then distribute. Doesn't matter which way you go. So cotangent. So now again, we said that cotangent could be 1 over tangent, or it could be that, cosine over sine. Well, I'm not going to use the 1 over tangent because there's no tangents here, so that's why I'll make my life easier, and I'll just write that as cosine over sine. And that's minus cosecant is having 1 over sine. Now we're going to distribute this through. Now if you did that first, then it doesn't matter because in the end we're all going to have this. Shift theta minus sine theta 1 over sine theta. Now, who can cancel? You can cancel with this guy. You can cancel with this guy. So then you're left with cosine theta minus, and the only thing left here is 1. Cosine theta minus 1. Choice number 4. Okay. The expression sine A plus cosine squared A divided by sine A is equivalent to what? Well, now the question here is, what the heck is this thing, right? When I'm looking at this, okay, I see this is, you're adding a fraction. Are you allowed to add these two fractions? Let me break it down even simpler. Could you add 2 plus 1 over 2? And you should say no, well, because you have to have what? The same denominator. So this guy has a denominator of 1, so I need a denominator of 2, so I would multiply this guy by 2 over 2, right? It's going to be the same thing, okay? So you could see how you're kind of taking elementary stuff and just doing it, but instead of it being a number, it's sign, right? So you can't add these two fractions. You can do nothing here. You can say, well, I could change this into 1 minus. Well, sure, but you still can't put them together. The goal is to get them together. So what I would say is, all right, I need to get a sine A in the denominator. So what you could do, let's write it over here so my face doesn't block you. Sine A plus cosine squared A over sine A. I would multiply this side by sine A. And then sine A times sine A is sine squared A over sine A plus cosine squared A over sine A. Now they have the same denominator, so I can now put it together and express it as one single fraction. And now what is sine squared plus cosine squared equal to? Well, we did that up here. Sine squared plus cosine squared is 1. So this becomes 1 over sine A. Now, if you look, they don't have 1 over sine A. They have sine A, but that's not the same. 1 over sine A is the same as having cosecant of A. And had a lot of layers to it. But there it is, okay? And like a puzzle, like anything else, you do it a couple times, then you'll start to get the idea, all right? Exercise 3, it's a couple more practice questions. Really try to maybe give yourself a chance to try to do these ones on your own. See if you can get them. Okay, they're not super difficult. They're totally solvable. All right, so express this as a single trigonometric function in simplest forms for all values of which it is defined, which means you can't have 0 in the denominator. All right. So cotangent x times sine x divided by secant x. Well, this guy's good. I like him. Let's change this guy, and let's change this guy. So cotangent is what? Cosine over sine. Secant is 1 over cosine. And this guy we didn't touch. Well, right away I'm going to be like, well, yeah, I'm going to get rid of that guy, right? So that's cosine x, right? Divided by 1 divided by cosine x. Here's that whole fraction thing again. So what do? We flip this guy, right? So then it's going to be cosine x times cosine x. What'd I do? Oh, cosine x over 1. Now what's cosine times cosine? Cosine squared. Over 1, but the 1 goes away. All right, so there you go. All right, let's try this guy here. Before you try to pause and try it on your own, little joke there. Cosecant squared theta. You might say, well, we didn't do that one. Well, we know cosecant is 1 over sine, so just make it 1 over sine squared. Okay, now you can pause and see if you can do it on your own. All right, so cosecant squared is the same as having 1 over sine squared, right? Tangent squared. So tangent squared is the same as having sine squared over cosine squared, right? Oh, I'm writing x, it's theta. And we're not going to touch this guy, right? So, oh look, those guys cancel. So you have a cosine squared on the bottom and a cosine on the top. So there's 1 here, and you're just canceling 1, so you're just left with 1 over cosine theta. Now it could stay there, or that's the same as having a secant theta. Okay, they could give you either or. And the last one. Okay, I would hope at this point you're like, oh, this one's easy. Secant is 1 over cosine. Sine, we'd want to leave her alone. Cotangent is cosine over sine. And let's see if this all cancels out and ends up with a 1. Sine, cosine, haha. Good. Awesome. So there it is, first lesson. Nice, easy introduction for you guys. Hope this helps. Link, subscribe, notifications. I don't know. Whatever you guys want.